Okay. So, hi everyone. So, good afternoon all. So, first of all, let me know whether audio and video everything clear. So, good afternoon all. So, first of all, let me know whether audio and video everything clear. So, please give some comment in chat box here. Is everything clear? Audio and video? Right. Okay. So, I hope it is clear here. I hope it is clear. If it is not clear, please give some comment in chat box. If it is not clear, please give some comment in chat box. Okay. Okay. Alok Kumar. Good afternoon, Alok Kumar. Okay. Okay. So, Alok Kumar, is everything fine now? Alok Kumar, Paras Moon. Is everything fine? Audio and video, is everything fine? Okay. Okay. So, I hope it is fine. So, we are dealing with the subject. Electromagnetics. We are dealing with the subject electromagnetics. So, in this we are dealing with the topic magnetostatics. Okay. So, in magnetostatics, we have started with what? We have started with Lorentz force equation. Okay. So, in general Lorentz force equation, I can write it as what? F bar is equal to what? F bar is equal to Q into E bar plus what? Plus V bar cross B bar. So, if you are having both electric field as well as magnetic field, then this is the Lorentz force equation. If you consider only B field here, right? So, Parasmoon. Sir, Banu sir is not taking electrical machine class. Please inform him to take it again. Yes, sir. Hope you know that sir is affected with corona. So, right now he is taking rest, right? Okay. Once he get recovered from that, okay, then he will continue the classes, right? So, don't worry about that here. So, for few days he will be in rest. Then after that, once he get recovered from corona, then he will take the classes, right? Okay. I think he has mentioned that in his Telegram group channel also, right? Okay. Okay. Okay, Parasmoon. Okay. Now, if I consider only B field here, so for B field, Lorentz force equation, F bar is equal to what? F bar is equal to Q into what? Q into V bar cross what? V bar cross V bar. Understood? So, based on this Lorentz force equation, we have seen different types of applications. Yes or no? Okay. So, we have solved different types of problems based on what? Based on this Lorentz force equation. Right? Okay. Okay. So, now today I will give you some problems here. Okay. So, you have to answer those questions here. Right? Okay. So, the applications what we have seen here, we have seen Hall effect, and also we have seen that whenever a conducting bar is moving in B field, okay, there induces an voltage across it. Yes or no? Okay. So, all these things we have seen in the previous sessions. So, now I will give you some questions here. You have to answer those questions. Okay. So, you have to do it here. And tell me the answers. Right. So, now here they have given that a 64 microcoulomb charge traveling with velocity V bar is equal to what? V bar is equal to 4 ax cap plus 2 ay cap meters per second enters in a region where magnetic field B bar is equal to what? B bar is equal to minus 5 ax cap plus 3 ay cap Tesla. Okay, find the magnetic force on the charge. They are asking to determine the magnetic force on the charge. What they have given here? They have given the charge here. They have given a charge of 64 microcoulomb. So that means they have given Q is equal to what? Q is equal to 64 microcoulomb. And they have given that this charge is moving with velocity. This charge is moving with velocity V bar is equal to what? Is equal to 4 ax cap plus what? Plus 2 ay cap meters per second. Right. So this is the velocity with which this charge is moving. Okay, it enters into a B field here. It enters into a magnetic field, that is B bar is equal to what? Is equal to minus 5 ax cap plus what? Plus 3 ay cap Tesla. Okay, now you have to determine the magnetic force. You have to determine the magnetic force on the charge. So they have given Q, and the velocity with which it is moving they have given, and in which field it is moving, in B field. So they have given B field also. Now they are asking to determine what? They are asking to determine the magnetic force on the charge. So that means they are asking to determine Fp, that is magnetic force. Okay, so do it here, do it and tell me the answer. Do it and tell me the answer. Do it here. So it is very simple problem here, simple and straightforward problem. Okay, so do it and tell me the answer. Alok Kumar, Parasmoon, do it here. So I will give you I think 30 seconds is enough here, right? Or you can take 1 minute here, or you can take 1 minute. Okay, so tell me the answer within 1 minute here. Tell me the answer within 1 minute. So I will wait for 1 minute here. You have to tell me the answer. Just apply the formula here. Just apply the formula. That's it now. Okay. So magnetic force is equal to what? Is equal to Q into what? Q into V bar cross what? V bar cross V bar. You know this one, right? So they have given Q value, they have given V bar value, they have given B bar value. Understood? If you know cross product, then you can tell the answer. So Alok Kumar, 1408 micronewtons in AZ cap direction. Okay, yeah. Very good here. Very good. Okay. So let us check here whether that answer is correct or wrong. Let us check. Okay. So anyway, if you are giving answer means you have followed the procedure, right? Okay. So if you get familiar with the procedure, then automatically by practice you can get familiar with the mathematical calculations also, right? Okay. So Fb bar is equal to what? So Q is nothing but what here? Q is 64 microcoulombs. So substitute 64 microcoulombs, that is 64 into 10 power minus 6 into what? Into V bar. V bar what they have given here? 4 AX cap plus what? Plus 2 AY cap. 2 AY cap. Cross what? Cross B bar. B bar is minus 5 AX cap plus what? Plus 3 AY cap. Understood? Okay. So this is cross product here. This is cross product. You have to do the cross product between these two. Okay. Okay. Yeah. So what you are going to get here? Here 64 into 10 power minus 6 into what? Into, so if you do the cross product, what you are going to get here? So first since you are having only AX cap and AY cap, there is no need to write in determinant form and all. Okay, you can directly calculate the cross product. Now here 4 into 4 AX cap here, 4 AX cap into here AX cap. AX cap cross AX cap will be 0. yes or no? Next, Ax cap cross Ay cap will give you what? Az cap. So 4 into 3, 12, yes or no? 12 Az cap, 12 Az cap. Next, 2 Ay cap cross what? Minus 5 Ax cap. So Ay cap cross Ax cap is nothing but what? Minus Az cap. Minus of minus will become what? Plus. Okay, so you are going to get plus 10 Az cap, plus 10 Az cap. Next, 2 Ay cap cross what? Ay cap will become 0. So this is the answer you are going to get here. Okay, so that is equal to what? That is equal to, so 64 into 10 to the power of minus 6 into what? 12 plus 10, that is 22 Az cap, 22 Az cap. So that is equal to what you are going to get here? So 64 into 22 here, 64 into 22 into 10 to the power of minus 6 Az cap. So this is the answer you have to get. Okay, okay, yeah. So 22 4s are 88, 22 5s are 22 6, 22 6, 6 2s are 12, 6 2s are 12, 130, 32 plus 8. Okay, so I think 1408, yes or no? 1408 10 to the power of minus 6 Az cap. Okay, so this is what you are going to get here. So this is the magnetic force. This is the magnetic force you are going to get. Okay. Okay, so I think Alok Kumar, you got the right answer, right? Okay. Yes, 1408 micronewton in Az cap direction. Very good here, very good. Okay, right. Next problem here, next problem. So I have just started with a simple problem, right? Okay, so next problem here. Next problem, see here. So here what they have given here? They have given that a particle having charge q is equal to what? Q is equal to 10 microcoulomb moves in uniform B field, with velocity v1 is equal to what? V1 is equal to 10 to the power of 6 meters per second at an angle 45 degrees, with x-axis in the xy plane. Okay, so what they have given here? A particle having a charge q moves in uniform B field with velocity v1 is equal to 10 to the power of 6 meters per second at an angle 45 degrees with respect to what? With respect to x-axis in xy plane. So let us consider this as x-axis and this as y-axis. So the charge particle is moving in uniform B field at an angle what? At an angle 45 degrees with respect to what? With respect to x-axis in the xy plane. Understood? And experiences a force of F1 is equal to what? F1 is equal to 5 root 2 minus Az cap. That means it is experiencing a force in which direction? Negative z direction. Understood? 5 root 2 minus Az cap millinewton. When the same particle moves with velocity v2 is equal to 10 to the power of 6 meters per second along z-axis. Okay, now what they have given here is now the same particle here, when it is moving with velocity 10 to the power of 6 meters per second, now in which direction it is moving? It is moving along z direction. So in this case they have given that it experiences a force F2 bar. In which direction here? In y direction. Then find magnitude and direction of B field and also find magnitude of F2 bar. Okay, so this is the question they are asking. So initially what they are saying here, a charge q is equal to what? A charge q is equal to 10 microcoulomb moves in a uniform B field. They have not mentioned anything about B field. Understood? So it is going to move in a uniform B field with velocity v1 is equal to 10 to the power of 6 meters per second at an angle 45 degrees with respect to what? With respect to x-axis. In which plane? XY plane. In XY plane. Okay, in XY plane. So in this case it is going to experience a force. In this case it is going to experience a force. F1 is equal to what? 5 root 2 minus AZ cap millinewton. That means it is going to experience a force in negative Z direction whenever it is moving at an angle 45 degrees with respect to x-axis in XY plane. Understood? Okay, so next what they have given, when the same particle here, when the same particle moves with velocity v2 equal to 10 to the power of 6 meters per second, in which direction? In Z direction. The same particle now it is moving with 10 power 6 meters per second along Z direction. Now in this case it is experiencing a force of what? It is experiencing a force of F2 bar in which direction? In Y direction. In Y direction. Now they are asking to determine what? They are asking to determine the magnitude and direction of B field, and also you have to determine the magnitude of what? Magnitude of F2 bar. Okay, so here you can consider case 1 and case 2 here. So in case 1 here, so initially what they are saying here, in case 1 what they are saying, so here they are saying that a charge q is equal to 10 microcoulomb. Okay, so it is moving. So let us consider this is x-axis and let us consider this is y-axis. So this charge q is moving in B field. It is moving in B field. Okay, they have not mentioned anything about B field here, whether it is in x direction, y direction, z direction, we don't know anything. Okay, so here you can assume some B field is present. Okay, but we don't know in which direction it is present. Understood? Okay, what they have given here is the charge q is moving with a velocity. It is moving with a velocity v1 is equal to what? Is equal to 10 to the power of 6 meters per second. 10 to the power of 6 meters per second with an angle what? It is making an angle theta is equal to what? Is equal to 45 degrees with respect to what? With respect to x-axis. Okay, so here some B field is present here. Here some B field is present. Okay, they have not mentioned anything about B field. So therefore I am considering B field is equal to what? Since they have not mentioned anything about B field, okay, so just I am considering B field is having what? Is having, let us assume it is having x component plus what? Y component. B field is a vector quantity or not? Okay, so in general it is going to have x component, y component as well as what? Z component. Since they have not mentioned anything about B field, just I am assuming B field is equal to bx ax cap plus by ay cap plus what? Plus bz az cap. Okay, so this is what I am assuming here. This is what I am assuming. Okay, so this is B field. This is B field. Understood? Okay, so whenever it is moving at an angle 45 degrees with respect to x-axis in B field, it is experiencing a force. It is experiencing a force F1 bar. F1 bar is equal to, they have given here, what is F1 bar? 5 root 2. It is experiencing a force of 5 root 2 in which direction? Minus AZ cap direction, millinewton. Sir, no, millinewton. Okay, so whenever it is moving at an angle 45 degrees in this B field, it is experiencing a force of 5 root 2 minus AZ cap millinewton. Okay, so this is case 1. This is case 1. Right. Okay. Now case 2 here. Case 2. So in the same B field here, they have not changed B field. They have not changed B field. They have not changed the charge particle. They have not changed the charged particle. So what they are saying here? What they are saying, when the same particle, that means the same charge q equal to, the same charge q is equal to 10 microcoulombs. The same charge, when the same particle moves with velocity v2 equal to what? V2 equal to 10 to the power of 6 meters per second. Now v2 is equal to 10 to the power of 6 meters per second. Now it is moving along what? Now it is moving along z direction. Okay, now here v2 is moving along z direction, so I am representing with AZ cap. It is moving along z direction. Understood? Along z axis. It experiences a force F2 bar in y direction. Now here they have simply said F2 bar is in which direction here? Is in ay cap direction. Is in ay cap direction. So that's what they have given. They have not given anything magnitude. They have not mentioned any magnitude of F2 bar. They are simply saying F2 bar is along what? Is along y direction. Understood? Okay. Is along y direction. Then you have to find what? You have to find the magnitude and direction of B field, and also you have to find out the magnitude of F2 bar. Now that means you have to determine B bar here. That means you have to determine B bar. So once you determine B bar, then you can determine its magnitude as well as what? As well as direction. And also you have to determine what? And also you have to determine magnitude of what? Magnitude of F2 bar. Magnitude of F2 bar. So already they have given F2 bar is in which direction? It is in y direction. So they are asking to determine what? To determine magnitude. Okay. Okay. So I will give you 2 minutes time here. I will give you 2 minutes time. Okay. So just try this one here. Just try this one. I am not expecting the answer. If you give answer, that is well and good. Okay. But I am not expecting the answer from you. So if you give the answer, it is well and good. It is super. Right. Okay. So I will give 2 minutes, just at least to try here. I have explained what they have given, each and everything I have explained, right? Okay. So give a try and try to tell me the answer within 2 minutes. Within 2 minutes, right? Okay. Amruta Anil, thank you so much for the lectures. Thank you, Anil. Let Bhanu sir recover from corona. Prayers for him. Okay, sure. Okay. He will recover soon here, no problem, right? So soon you are going to have machine lectures also, right? Okay. Okay. So Alok Kumar, B field is equal to 10 to the power of 6 in AY cap. So I got one answer here. I got one answer. So that is B field. B field you have given as 10 to the power of 6, right? 10 to the power of 6 in AY cap direction. 10 to the power of 6 or 10 to the power of minus 6? You have given 10 power 6, right? Okay, one answer I got. Is there any other answers here? Parasmoon, tell me here. Is there any other answers? Okay. So 30 seconds completed here. 30 seconds completed. Parasmoon, what is your answer? Tell me here, is there any other answers? Right. So 1 minute completed here. 1 minute completed. So 1 more minute I am giving here. Let's see. Okay. Okay, yaar, 10 more seconds. So it doesn't seem that I am going to get some more answers. Okay. Okay, yaar. See here. So here, case 1 here. Let us consider case 1. So case 1. Right. So here they have given that. Here in case 1 they have given that F1 bar is equal to what? Is equal to 5 root 2 into minus AZ cap. Right. Next V1 bar here. V1 bar. So V1 bar is equal to what? Is equal to 10 to the power of 6 meters per second, and it is making an angle theta equal to 45 degrees with respect to x-axis. So that means what here? That means this is x-axis and this is nothing but what? V. Right. Okay. So this angle is what? This angle is 45 degrees. 45 degrees. Now see here, and this is what? This is y-axis. This is y-axis. Now this velocity vector is neither along x nor along y. So I can resolve this into two components. One is what? One is along x direction. Okay. So what is its x component here? Its x component will become v cos 45 degrees. Yes or no? And what is its y component? Its y component will become what? Its y component will become v sin 45 degrees. V sin 45 degrees. Understood? So therefore V1, you can write it as what? You can write it as, so V1 bar is equal to what? Is equal to V into, sorry, this is V1 here. This is V1. Right. So V1 is equal to V1 into cos 45 degrees. Cos 45 degrees AX cap plus what? Plus V1 into sin 45 degrees AY cap. So in this manner you have to write the velocity vector. So therefore V1 bar is equal to what? Is equal to V1. I can take V1 common, then what you are going to get? Cos 45 is 1 by root 2. Here also you are going to get 1 by root 2. So you can take 1 by root 2 also common. So V1 by root 2 I can take common into what? Into AX cap plus what? AX cap plus AY cap. So this is nothing but V1 bar here. This is nothing but V1 bar. Okay, and this is nothing but what? This is nothing but F1 bar. And B field here, B field. So B field, we have considered it as what? We don't know B field. So we are assuming it is having x component plus what? Plus y component plus what? Plus z component. Plus z component. Okay. So we don't know anything about B field. So we are assuming it is having x component as well as y component and z component. Right. Okay. Okay. Now just apply Lorentz force equation here. Just apply Lorentz force equation. So what you are going to get here? What you are going to get? See here. So F1 bar is equal to what? F1 bar is equal to Q into what? Q into V1 bar cross what? V1 bar cross B bar. V1 bar cross B bar. Now here V1 bar they have given us what? Sorry, F1 bar they have given us 5 root 2. So this is equal to 5 root 2 minus AZ cap. Okay. So this is equal to Q. Q value is how much here? Q value they have given us 10 microcoulomb. So Q value is 10 microcoulomb. Okay. Now you have to determine this V1 bar cross B bar. So V1 bar I can write it as what? This is having x component, y component and z component. So V1 bar I can write it as what? So I can write it as V1 by root 2 here, and for AX cap it is 1 and AY cap it is 1, right, and AZ cap is 0. Next for B bar I can write it as what? It is having x component, y component and what? And z component. So if you do this, what you are going to get? What you are going to get? Tell me. So you are going to get V1 by root 2 into what? Into see here what you are going to get? Ax cap into what? Bz minus 0. So that means Bz Ax cap. You are going to get Bz Ax cap right now. So Bz Ax cap. Next, minus Ay cap. Minus Ay cap into what? Okay. So minus Ay cap into what? Tell me. So minus Ay cap into Bz minus 0. Yes or no? So Bz minus 0, that is Bz. Right. Next, Az cap into By minus Bx. Right. Plus Az cap into By minus Bx. Okay. So this is what we got, V1 bar cross B bar here. So this is equal to what? This is equal to Q is 10 microcoulomb, and here in place of V1 bar cross B bar, I can substitute that result. So what I am getting here? What I am getting? So V1 by root 2 into what? Into Bz Ax cap minus Bz Ay cap. Right. Plus By minus Bx Az cap. Okay. So this is what you are getting here. This is what you are getting. Now you have to compare here. Compare the components on both sides. So if you observe on LHS side, the x component and y component are 0. The x component and y component are 0. So equate the x component to 0 here. Equate the x component to 0. Here the x component is nothing but what? X component is nothing but Bz. Understood? Okay. So comparing here, comparing the components on both sides. What you will get? You will get Bz is equal to what? Bz is equal to 0. Right. And y component is also 0. So what is y component here? You are having Bz. So again you are getting what? Bz is equal to 0. Next, compare z component here. So what is the z component? If you compare, so here you are having 5 root 2 minus Az cap, that is equal to what? That is equal to 10 microcoulomb into what? V1 by root 2. V1 value is what here? V1 value is 10 to the power of 6 meters per second. So into 10 to the power of 6 meters per second divided by what? Divided by root 2 multiplied by what? Multiplied by By minus Bx Az cap. Okay. So I am comparing the z component on both sides. So if you compare x component, you got Bz is equal to 0, and if you compare y component, you are getting the same result, that is Bz is equal to 0. So that means the z component of B field is equal to what? Is equal to 0. So that's what we can conclude. Right. Okay. So from here, what we are going to get here? From here, what we are going to get? Tell me. From here, what we are going to get? Here micro, yes or no? Micro means what? Micro means 10 to the power of minus 6. So here 10 to the power of minus 6 and here 10 to the power of 6 will get cancelled. Right. Okay. Now here 5 ones and here 5 twos. Here root 2 ones and here you will get root 2. Again here root 2 and here root 2 will get cancelled. So if you compare the z components, what you are going to get? You are going to get By minus Bx. By minus Bx is equal to what? Is equal to what you are getting here? By minus Bx is equal to what? By minus Bx is equal to what? Is equal to minus 1 here. You are having minus 1. So that means I can write Bx minus By. Bx minus By is equal to what? Is equal to 1. Okay. So this is the conclusion I got from what? From case 1. This is the conclusion I got from case 1. So that is Bx minus By is equal to what? Is equal to 1. Right. Okay. So what is left out here? What is the coefficient of Az cap? Minus 1. And here what is the coefficient of Az cap? That is By minus Bx. So By minus Bx is equal to minus 1. So that means I can write it as Bx minus By is equal to 1. Understood? Okay. So this is equation 1 here. This is equation 1. Next here, next case 2 here, case 2. So in case 2, what they have given here? Case 2. In case 2, what they have given? Tell me. in case 2, so Q is equal to 10 microcoulomb, V2 is equal to what? 10 power 6 meters per second, AZ cap, and F2 bar is in which direction? AY cap direction. Okay, so this is the data they have given for case 2. Okay, for case 2, this is the data they have given. So from here, so here also you can apply what? You can apply Lorentz force equation, right? Okay, so what you are going to get? F2 bar is equal to what? F2 bar is equal to Q into what? Q into V2 bar cross what? V2 bar cross B bar, V2 bar cross B bar. So now here Q is equal to 10 microcoulomb, 10 microcoulomb. Now here what is V2 bar cross B bar here? So now here V2 bar cross B bar, so that is AX cap, AY cap, AZ cap. Now V2 bar is having only one component here. V2 bar is having only one component, that is which component? That is Z component. X component of V2 is 0, Y component of V2 is also 0. So you can put here 0, 0, right? Okay, and it is having only Z component. So here I can write 10 power 6 outside, okay, and here I can write 1 here. I can write 1. Okay, next B bar here. So B bar, we know that B bar, the Z component of B bar. So here we have concluded that the Z component of B bar is equal to what? Is equal to 0, right? Okay, so the Z component of B bar is equal to 0, and it is having only X component and Y component, X component and Y component. Understood? So this is what we are going to get. So here, okay, okay, so 10 microcoulomb here into 10 to the power of 6 into what? Into, so do this cross product here, what you are going to get? So if you do AX cap into what you are going to get? 0 AX cap into 0 minus BY. So you are going to get minus BY. Next, minus AY cap into 0 minus BX. So you are going to get minus BX. Next, plus AZ cap into what? Plus AZ cap into 0 here, plus AZ cap into 0. Understood? Okay, so this is what you are going to get. Now here micro means what? Micro means 10 to the power of minus 6. So here 10 to the power of minus 6, 10 to the power of 6 will get cancelled. Okay, so you can write simply 10 into what? 10 into minus by AX cap. Here minus into minus will become plus BX into what? Plus BX into AY cap. Here Z component is what? Z component is 0. So here they have given that F2 bar is in which direction here? It is in AY cap direction. I don't know the magnitude here. I don't know the magnitude of F2 bar, but they have given what? They have given the direction of F2 bar. So what is the direction? AY cap direction. So F2 bar, its magnitude is F2 bar, right? And its direction is what? Its direction is AY cap. Now you have to compare. You are equating the vectors on both sides. Okay, if you observe on LHS, you are having only Y component. You are having only Y component. Understood? So that means X component and Z component on LHS side is equal to 0. So if you equate the components on both sides here, what you are going to get? Here the X component is 0. Yes or no? Here the X component is nothing but what? Minus BY. So what you are going to get? Minus BY is equal to what? 0. So that means BY is equal to what? BY is equal to 0. BY is equal to 0. That means the Y component of B field is also what? Is also equal to 0. Right. Next here, now compare the Y components on both sides. So what you are going to get here? 10 into BX here, 10 into BX, right? So 10 into BX is equal to what? Is equal to F2. Okay, so that is magnitude of F2 here. 10 into BX is equal to magnitude of F2. So this is what you are going to get. Right? Okay. Now here By is also equal to 0 here. By is also equal to 0 and Bz is also equal to 0. That means B field is going to have what? Only X component. Right? Okay. So now see this equation here. See this equation 1. So see this equation 1. Okay. uh, wait. See here, F1 bar is equal to what? 5 root 2 minus AZ cap millinewton here. So I think I have forgot to represent a millinewton, right? So right here millinewton, right? Okay. So millinewton means here you have to write what? Into 10 to the power of minus 3 here, right? So millinewton, I am adding millinewton here. So millinewton means into 10 to the power of minus 3. Okay, so that means here you are going to get minus 1 into what? Minus 1 into 10 to the power of minus 3. So here you are going to get 1 into 10 power minus 3, that is 10 power minus 3. So this is the equation you are going to get here. Bx minus by is equal to what? 10 to the power of minus 3, right? Okay, because here I forgot to mention millinewton, that is 10 to the power of minus 3 Newton, right? Okay, so please correct that one here. So now from this expression here, from this equation, okay, so from this equation, what you are going to get here? What you are going to get? So we know that by is equal to what? By is equal to 0, and also we got what? Bz is also equal to 0. Understood? So only bx is going to left out. So therefore bx is equal to what? Is equal to 10 to the power of minus 3 Tesla. 10 to the power of minus 3 Tesla. Okay, so that means therefore B field here. Therefore B field. So what we have assumed? B bar is equal to what? Is equal to bx ax cap plus what? By ay cap plus what? Bz az cap. So we got Bz is equal to 0, By is also 0, Bx is equal to what? 10 to the power of minus 3 Tesla. So therefore B bar is equal to what? B bar is equal to 10 to the power of minus 3 Ax cap Tesla. Okay, so this is the B field here. Finally we got the B field. So B field is having only one component, that is X component, that is Ax cap. Understood? Now if you know B bar, then you can determine what? You can determine F2 bar. They have asked to determine the magnitude of F2 bar also. So therefore magnitude of F2 bar here, magnitude of F2 bar is equal to what? 10 into Bx. So Bx is 10 power minus 3. 10 power minus 3. So that is equal to what? 10 to the power of minus 2 Newton. So this is the magnitude of F2 bar. And in which direction they have given F2 bar? F2 bar is in Ay cap direction. Understood? Okay. Okay. Yeah. So this is the magnitude of F2 bar, and this is the B field you are going to get, that is 10 to the power of minus 3 Ax cap Tesla. Right? Okay. Is this problem clear here? Tell me. Is this problem clear? Tell me here. They have given two situations here. Okay. So with the help of those two situations, you have to determine what? You have to determine the B field, and also you have to determine the magnitude of what? Magnitude of force F2. Right? Tell me here, is this problem clear? Tell me. Alok Kumar, Paras Moon. Clear? Rahul Thakur. Okay. Okay. So these are all just for practice here. So you will get practice with how to do this cross products and all these things, okay, and how to apply this Lorentz force equation and all these things here. So it will be just like a practice, right? Okay. Okay. Yeah. So next. Okay. Next here, see here. Okay. See F bar is equal to Q into V bar cross what? V bar cross B bar. Okay, okay. So here we know that F bar is perpendicular to what? F bar must be perpendicular to what? Perpendicular to B bar. Yes or no? And also F bar is perpendicular to what? V bar or not? Yes or no? See here, V bar cross B bar is going to result in a vector that is perpendicular to what? That is perpendicular to both V bar as well as what? B bar. Understood? So that means here the force direction is perpendicular to what? Is perpendicular to both V bar as well as what? As well as B bar. Yes or no here? So that means F bar is perpendicular to B bar. So this already we have seen. So next, another conclusion what we can draw here, F bar is also perpendicular to what? Is also perpendicular to V bar. F bar is also perpendicular to V bar. Yes or no? Okay, okay. Yeah. So now here tell me if suppose the charge is moving in a uniform B field with a uniform velocity. Let us assume a charge Q is moving in B field with a uniform velocity. So then what is the work done? What is the work done by the B field on that moving charge? What is the work done by the B field on that moving charge? Tell me here. How you can determine the work done on the moving charge in B field? So what my question is, what is the work done? What is the work done? What is the work done by the B field? What is the work done by the B field on the moving charge? So moving charge means it is moving with uniform velocity. So B field means it is uniform B field, right? Okay, so remember these things. So what is the work done by the B field on the moving charge? So a charge Q is moving with velocity V in B field B. Then what I am asking here is, what is the work done by the B field on the moving charge? So that's what I am asking. Okay, tell me here, what is the work done? Tell me whether it is a 0 or non-zero. Tell me that. Whether the work done by the B field on the moving charge is 0 or non-zero. Tell me that here. I am not asking any expressions here. I am just asking whether it is equal to 0 or not equal to 0. So tell me that. Alok Kumar, Rahul Thakur, Paras Moon. Tell me here. Tell me. Work done by the B field on a moving charge is equal to 0 or not equal to 0? Tell me. Alok Kumar said 0. Rahul Thakur, Paras Moon. What is your answer here? What is your answer? Tell me. Alok Kumar has told 0. Alok Kumar, can you just briefly tell how you are getting 0? Just tell that logic, that's it. Why you are saying 0? So just tell that logic, that's it. Okay, okay, see here. See, work done here. Work done is nothing but what? Work done is nothing but force dot displacement. Yes or no? Work done is equal to what? Is equal to force dot displacement. So work done by the B field here. Work done by the B field is equal to what? Force dot displacement. So that is equal to F bar is nothing but what? Q into V bar cross B bar dot what? Dot L bar. Dot L bar. Now here the velocity and the displacement direction both must be same or not? Yes or no here? The direction of velocity and the direction of displacement both must be same or not? See, we know that velocity is equal to what? Velocity is equal to displacement by time. Displacement by time. So that means the direction of displacement and the direction of velocity both are same. Both are same. Understood? Okay, so that means if I consider the velocity is in x direction, let us assume velocity is in x direction and B field is in y direction, let us assume, and the displacement here, the displacement I am representing with L bar, the direction of displacement must be same as what? The direction of velocity. So that means this displacement is also in which direction? X direction. Understood? Okay, so now here in this case what you are going to get here, the resultant of this one is going to point in which direction? So the resultant of this cross product is going to point in z direction, yes or no? So here it is going to point, the result is going to point in z direction, and here you are doing the dot product, here the displacement is in which direction? X direction. Understood? So if you do the dot product between az cap dot ax cap, what you are going to get? You are going to get what? You are going to get 0. Understood? Why here? Because here the force and the velocity here, the force and velocity both are what? Both are perpendicular to one another, and the direction of displacement must be same as what? Direction of velocity. So that means force and displacement are also what? Are also perpendicular to one another. So since force and displacement are perpendicular to one another, the work done by the B field on a moving charge is equal to what? Is equal to 0. Is equal to 0. Okay, so that is the conclusion we can make here. So therefore you can make a note. So what is the note here? So work done by the B field. Okay, so work done by B field on a moving charge is equal to what? Is equal to 0. Is equal to 0. Okay, work done by the B field on a moving charge is equal to 0. Force is not equal to 0 here. Force is acting, yes or no? Force is present, but the force and displacement both are perpendicular to one another, and hence work done by the B field on moving charge is becoming equal to what? Is becoming equal to 0, right? Okay. Parasmoon, what you are asking here, is B field a conservative field? I will tell here, I will tell each and everything. Okay, so don't worry about that, I will tell. Okay, so we have not started at Ampere's law and all those things. Okay, there I will tell each and everything, don't worry about that. So if you want immediate result, B field is not a conservative field, right? Okay. Okay, here. See here, work done by the B field on a moving charge is equal to 0. So what do you mean by this here? What do you mean by this? See here, if suppose a person is moving like this here, a person is moving like this, okay, with some velocity, with some speed here, with some speed. I am not saying velocity, I am saying speed, right? Okay, so a person is running with some speed like this, okay. So now if I apply a force on that person here, his speed is going to change or not? Yes or no here? So whenever I apply a force on that person, what will happen? His speed is going to change. Understood? So I have applied a force as well as this object or that person is having some displacement. So force dot displacement will give you what? Will give you work done. So will give you work done. So that means whenever I do some work here, what is happening? There will be a change in what? There will be a change in speed. A person is running or moving like this. Understood? Okay, so whenever I apply a force on that person, what will happen? His speed is going to change. Understood? Okay, so I have applied a force and this person is having some displacement. That means I have done some work. So that means whenever I have done some work, the speed of that person is changing. Understood? So if the speed is changing means the kinetic energy is also changing. Understood? Okay, so if suppose, if so, that means the final conclusion is whenever you do some work here, whenever you do some work, there will be a change in speed, there will be a change in speed. But here I am saying that work done by the B field, work done by the B field on a moving charge is equal to 0. So that means if the charge is moving in a B field, if the charge is moving in a B field, the work done by the B field on that moving charge is equal to 0. That means that B field is not going to change, is not going to change the speed of what? The speed of the moving charge. That means if it is moving with some uniform velocity, then it continues to move with the same uniform speed, not velocity here. If it is moving with some uniform speed, then it continues to move with what? It continues to move with the same speed, because the work done by the B field on the moving charge is equal to 0. So that means there will be no change in what? There will be no change in the speed of the moving charge whenever it is moving in a uniform B field. Understood? Okay. So a uniform B field is not going to alter here. It is not going to alter the speed of the moving charge. It is not going to alter or change the speed of what? The speed of moving charge, because the work done by the B field on the moving charge is equal to 0. So this is the conclusion we can make. Right? Okay. Okay. Yeah. So what I am saying here? What I am saying here? Is this point clear here? Tell me. Is this point clear? So since work done by B field is equal to 0 implies what here? Implies implies that B field is not going to alter the speed of what? Is not going to alter the speed of what? The speed of moving charge. B field is not going to alter the speed of what? Speed of moving charge. But what it can do here? But it can at most change the direction of what? But it can at most change the direction of what? But it can at most change the direction of moving charge. Okay, how it is going to change the direction of moving charge, that we are going to see now. Okay, so this point is very, very important here. This point is very, very important. Okay, so since the work done by the B field on the moving charge is equal to 0, this implies that B field is not going to alter the speed of what? The speed of the moving charge, but it can at most change the direction of what? Change the direction of moving charge. Understood? Okay, so is this point clear? Tell me here. Parasmoon, Rahul Thakur, Alok Kumar, tell me, is this point clear? Tell me. Parasmoon, B field is not a conservative field. It is not a conservative field. We are going to study that here. Don't worry about that. Okay. Is this point clear? Tell me. B field is not going to alter the speed of the moving charge, but it can at most what? But it can at most change the direction of what? Change the direction of moving charge. Why it is not able to alter the speed of moving charge here? Because the work done by the B field on the moving charge is equal to 0. If the work done is equal to 0 means it is not going to alter the speed. It is not going to alter the speed of the moving charge. So what it can do here? It can at most change the direction of the moving charge. So tell me here, we will see how it is going to change the direction of moving charge, that we are going to see now. Okay, but at least have you understood that B field is not going to alter the speed of moving charge? Have you understood this point here? Tell me here. Alok Kumar, Parasmoon, Rahul Thakur. Tell me here. Understood or not? Say something here. Okay. So now we will see how it is going to change the direction of the moving charge. See here. So let us consider this as y-axis and let us consider this as x-axis. Okay. Let us consider this as x-axis and let us consider this as y-axis. Rahul Thakur, what is the effect on velocity? Everything I will tell here, everything I will tell. Okay. So what I am saying is, if the work done is equal to 0 means its speed is not going to change. Its speed is not going to change. Understood? Speed is a scalar quantity. Speed is a scalar quantity. Whereas velocity is what? Velocity is a vector quantity. Understood? Okay. So velocity is a vector quantity means it is going to have what? It is going to have both magnitude as well as what? As well as direction. See here. See here. See, I will give you one example. So as you are asking this, I will give you one example here. See here. See, if I consider a circular path, let us consider a circular path here, right? Okay. Let us consider a circular path. So let us say its radius is some capital R. Now here, let us assume a car here. Let us assume a car is moving here. So let us assume this is car, right? Okay. So a car is moving, let us say this point, let us say this point, at this point. Okay. So a car is moving like this. Let us assume the car is moving. Let us say this point is A, right? So here the velocity of the car at this location, how you have to represent here? Whenever an object is tracing a circular path here, so the velocity at each and every point is given by what? Is given by the tangent. Yes or no? Tangent drawn at that point. So now here the car is moving like this means here its velocity is given by what? Is given by the tangent, is given by the direction of velocity is given by the tangent drawn at that location, So let us consider its velocity is what? Its velocity is V. So let us say this is VA. Let us say this is VA. Understood? VA bar. I am representing this as VA bar. Right. Okay. Now let us assume it has reached to this location here. It has reached to this location. Okay. So here this angle is 90 degrees. The angle between this A point and let us say this point is B. So this point is B. Now here the car is present here. The car is present here. Understood? So whenever it is present here, so what is the direction of velocity here? What is the direction of velocity? It is going to move in this direction. Let us say this is VB bar. Let us say it is VB bar. Okay. So now here let us consider car is moving. I want to give you the difference between speed and velocity. That's what I am saying, right? Okay. So let's consider car is moving with uniform speed, or I can say uniform velocity, okay, or okay. So I can say with uniform speed. Okay, with uniform speed. Let us say that VR, that speed I am representing with V. V is equal to, let us say, 20 meters per second. So speed I am representing with V, or you can consider magnitude of V. Okay. So let's consider a car is moving with uniform speed V equal to 20 meters per second on circular track. Okay. So first question here I am giving, determine the change in speed. speed between B and A points, between B and A points. Next, second one, I am asking determine the change in velocity, determine the change in velocity between B and A points. Now tell me here, now tell me. So what I have given here, so a car is tracing this circular path, a car is tracing this circular path. So the velocity of the car at any point is given by what? Is given by the tangent drawn at that point. Understood? So whenever the car is moving at point A, its velocity is going to point in this direction. So it is going to move like this, it is moving like this. Let us assume it is moving like this. So it is moving like this. Now whenever it reaches to point B, the velocity is going to point in downward direction. So similarly it is moving like this. At this location it is going to point in this direction. At this location it is going to point in this direction. So what I am saying here is it is moving with what? It is moving with uniform speed. That means the magnitude of velocity is same. The magnitude of velocity at each and every location is same. So that's what I am saying here. So now here in the first question, what I am asking here, determine the change in speed between what? B and A. B and A. So that means here you have to determine what? You have to determine the magnitude of VB minus what? Magnitude of VA. So what you are going to get? Tell me. So speed, the change in speed is equal to what? The change in speed will be equal to 0. Yes or no? So they have said that it is moving with a constant speed, that is 20 meters per second. So at VB the magnitude is 20 meters per second. At VA also the magnitude is what? The magnitude is 20 meters per second. So for the first question, what you are going to get? You are going to get VB minus VA is equal to what? Is equal to 0. Understood? Okay. Next, what they are asking, determine the change in velocity between between point B and A. So that means here they are asking VB bar minus what? VB bar minus what? Minus VA bar. So this is what they are asking. Understood? Now it becomes what here? It becomes vectorial summation. Understood? It becomes vectorial summation. I have already told that whenever you are adding any two vectors, it always depends upon what? It always depends upon the angle between those two vectors. Yes or no? Now if you observe here, VA bar is pointing in this direction here. VA bar is pointing in this direction, right? So VA bar is pointing like this and VB bar is pointing downward. So VB bar is pointing downward, right? So VB bar is pointing downward. Now here, what is the angle between these two? The angle between these two is nothing but what? Is nothing but 90 degrees. Understood? The angle between these two is nothing but what? Is nothing but 90 degrees. Now here, they are saying VB bar minus VA bar. So this is VB bar, this is VA bar. Now if I want to write minus VA bar, how I can write here? This is VA bar, this is VB bar. Okay. So now here this is nothing but what? This is nothing but VB bar, and VA minus VA bar is nothing but what? Opposite to this one. So this will become what? This will become minus VA bar. This will become minus VA bar. Now here this this angle is equal to what? 90 degrees. This angle is 90 degrees. Now what is the change in velocity? Tell me. Now what is the change in velocity? Tell me here. What is the change in velocity? Tell me. What you are going to get? So the change in velocity is nothing but what? Is nothing but so here, okay, or what you can do here? Okay, so wait. Okay, so here VB bar minus VA bar is nothing but what? So if you add these two vectors, what you are going to get? The resultant vector here. The resultant vector. How you are going to get the resultant vector? So from parallelogram law of forces, the resultant vector is going to point in this direction. Yes or no? So this is the resultant vector. This is the resultant vector. So what you are going to get? You are going to get VB bar minus what? Minus VA bar is equal to what? Is equal to VR bar. VR bar. Understood? So now what is the magnitude of this VR bar here? VR bar will give you what? Will give you the change in velocity, the change in velocity between point B and point A. So now what is the magnitude of VR bar? Tell me, what is the magnitude of VR bar? What you are going to get? Square root of what? Square root of VB square plus what? Square root of VB square plus VA square. That is equal to what? That is equal to 20 square plus what? 20 square. What you are going to get? You are going to get 20 root 2 meters per what? Meters per second. 20 root 2 meters per second. So that means the change in velocity here, the change in velocity is not equal to what? Is not equal to 0, whereas change in speed is equal to what? Change in speed is equal to what? Change in speed is equal to 0. Okay, so there is a difference here. There is a difference between speed and what? Speed and velocity. So speed is having only magnitude, whereas whenever you are talking about velocity, even though the magnitude of velocity is same, here the magnitude of velocity at each and every point is same here, but the difference between VB bar and VA bar, you are not getting what? You are not getting 0, because it is vectorial summation. So the vectorial summation will always depends upon what here? Will always depends upon the angle between those two vectors. So if the direction is changing, then the change in velocity is not equal to what? Is not equal to 0. Understood? Okay, but here the change in speed is equal to what? A change in speed is equal to 0. So if any object is tracing a circular path with uniform speed, with constant speed, understood? So then the change in speed may be equal to 0, but the change in velocity is not equal to what? Is not equal to 0. So this is what you have to understand. That is the difference between speed and velocity, right? Is it clear here? Rahul Thakur, Parasmoon, Alok Kumar, tell me here, is this clear? See, minus VA bar is pointing in this direction, VB bar is pointing in this direction, so the resultant vector is going to point in this direction. Understood? Okay, so from this here, from this you can form a right angle triangle. So from here, VR bar is equal to what? VR bar magnitude is equal to square root of what? Square root of VB square plus what? VA square, that is equal to square root of 20 square plus 20 square, that is 20 root 2 meter per second. Understood? Okay, is this clear here? Tell me. Okay, tell me here. Alok Kumar, Parasmoon, Rahul Thakur said yes sir. Okay, Alok Kumar, Parasmoon, tell me here, is it clear? Okay, so now see here. So here I have said whenever the charge is moving with uniform velocity, whenever the charge is moving with uniform velocity in a B field, then the work done by the B field on that charge will be equal to 0. That means this B field is not going to alter the speed of the moving charge, but it can at most what? But it can at most change the direction of the moving charge. So how it is going to change? That's what I am going to explain here. Now let us consider the B field. Let us consider B field is pointing into the board here. Let us consider B field is pointing into the board. Let us consider B field is pointing into the board. Alok Kumar, Parasmoon, are you there here? Are you listening? I don't know whether you are present or not. Okay. So this is B field here. This is B field. See, if you are having any doubts, please ask me here. Don't hesitate to ask any doubts. Okay, you can ask any doubt. Okay, so this is B field here. Let us say this is B field. Okay, so now see here. Okay, so let us say the charge, let us say a charge Q, let us say a charge Q is moving here. Let us say a charge Q is moving initially in which direction here? Initially let us say it is moving in X direction. Initially let us say a charge Q is moving in B field along X direction. So whenever it is moving along X direction, then in which direction it is going to experience the force here? In which direction it is going to experience the force? Tell me here. Rahul Thakur, if body moving with a constant speed, afterwards the body having certain acceleration. Now here what you are asking, if body moving with constant speed, afterwards the body having certain acceleration. Complete the question here. What you are asking? If the body is moving with constant speed, if the body is moving with constant speed, then Rahul Thakur, be specific here. I have not understood your question. If body is moving with constant speed, okay, fine. So afterwards the body having certain acceleration. What do you mean by that? See, acceleration is not related to speed. Acceleration is related to velocity. Acceleration is equal to what? Acceleration is a vector quantity. Yes or no? Acceleration is equal to dv bar by what? dv bar by dt. Right? Okay. It is nothing to do with speed. Right? Okay. Be specific with your question. I will answer that. Okay. See here. Now here let us assume the charge is moving here. The charge is moving initially along X direction. Along X direction. Understood? Then in which direction it is going to experience the force here? We know that whenever the charge is moving with some uniform velocity in a B field, it is going to experience a force. So what is that force here? That force F bar is equal to what? F bar is equal to Q into what? Q into V bar cross what? V bar cross B bar. Now here initially the velocity is in which direction here? The velocity is in X direction. It is moving in X direction. So the velocity initially in X direction and the B field is pointing into the board. So into the board means which direction here? Negative Z direction. Negative Z direction. That means B field is in negative Z direction. So if B field is in negative Z direction and velocity is in X direction, in which direction it is going to experience the force? Now you have to tell me the answer here. In which direction it is going to experience the force? Tell me. Rahul Thakur, because change in velocity is non-zero, that's why. Yes, if change in velocity is not equal to 0, then it is going to have acceleration. Understood? Okay. See, whenever a body is circulating with a uniform speed on the circular path, okay, so its velocity will change here because its direction is changing. Even though it is moving with uniform speed, since its velocity is changing because its direction is changing and hence the velocity is changing. So if the velocity is changing, then what will happen? The change in velocity, we can call it as what? Acceleration. So whenever a body is circulating, tracking or circulating along a circular path, it is going to have what? Its acceleration is not equal to 0. It is going to have some acceleration. That acceleration, we call it as what? We call it as centripetal acceleration. Okay. So we don't go into that much depth here. So whatever we have studied, that is more than enough. Right. Okay. Okay. So velocity is in x direction and B field is in what? Negative z direction. So what you are going to get? X cross z is minus y, minus of minus will become plus y. So the magnetic force will be in which direction? Y direction, y direction. So that means this charge is going to experience a force, along y direction, So whenever the charge is moving like this here, the charge is moving like this, now it is experiencing a force. Whenever it is moving like this, it is experiencing a magnetic force in upward direction. So then how it is going to move here? See, it is just like if suppose a person is moving on a scooter here. Suppose a person is moving on a scooter like this. Okay. So I have put some thread or something else. Okay. So then I try to pull that person here towards me. Okay. He is moving like this. Okay. So I have put some thread and I am trying to pull that person towards me. So whenever I pull that person towards me, what will happen here? What will happen? He won't come directly towards me or not? Yes or no? Because he is already in motion. So whenever I put some thread and try to pull that person, what will happen? So he is going to take what? He is going to take a curved path. Yes or no? Whenever it is moving like this, and if I apply a force like this towards me, then what will happen here? He is going to take a curved path like this. Understood? So similarly, so whenever the charge is moving, it is already moving with some uniform velocity. So whenever it is moving with some uniform velocity along x direction, so there acts a magnetic force in upward direction. So whenever the force is pulling the charge in upward direction, what will happen? Already it is in motion, so it is going to take what? It is going to take a curved path here. It is going to take a curved path. Understood? It is going to move like this. Okay. So it is going to trace a curved path like this, and finally it tries to move along what? It tries to move along y direction. Now here the charge is moving like this. Now the charge is moving like this, right? Okay. So whenever the force is acting like this, so it is going to move what? It is going to take a curved path and tries to move along what? Now it is moving along y direction. Understood? Now the charge is moving along which direction here? Y direction. So whenever the charge is moving along y direction, in which direction it is going to experience the force? So write down the force equation, that is F bar is equal to what? Q into what? Q into V bar cross what? V bar cross B bar. V bar cross B bar. Okay. So now here the velocity is in which direction here? Y direction, and B field is pointing in which direction? Negative z direction. So what you are going to get? Y cross z will be, y cross z is x. Here you are having minus, so it is going to experience the force in negative x direction. So whenever the charge is moving along y direction, it is going to experience the force. It is going to experience the force in which direction? In negative x direction. In negative x direction. Understood? Okay. So whenever it is experiencing the force in negative x direction, then what will happen here? Again, it is going to take what? It is going to take a curved path and tries to move along what? And finally tries to move along negative x direction. It tries to move along negative x direction. Now the charge is moving in negative x direction. So whenever the charge is moving in negative x direction, then in which direction it is going to experience the force? F bar is equal to Q into what? Q into V bar cross what? V bar cross B bar. Now the velocity is in which direction? Negative y direction. B field is in negative z direction. So y cross z, minus into minus will become plus. Y cross z is nothing but what? Is nothing but, sorry, it is moving in which direction here? Sorry here. Velocity is in which direction? Now it is moving in negative x direction, right? Okay. So it is moving in negative x direction. So minus into minus will become plus. X cross z is nothing but what? Minus y. So it is going to experience the force in negative y direction. So this charge is going to experience the force in negative y direction. In negative y direction. So whenever it is experiencing the force in negative y direction, so the same thing here. So it is going to take a curved path and tries to move in which direction? Tries to move in y direction, negative y direction. Now here the charge is moving in negative y direction. Okay. The same thing here. So F bar is equal to what? F bar is equal to Q into V bar cross B bar. Now V bar is in which direction? V bar is in negative y direction. It is in negative y direction. B field is in negative z. So minus into minus will become plus. Y cross z is nothing but what? Is nothing but x. So force will be in positive x direction. So it is going to experience the force. It is going to experience the force in which direction? In positive x direction. So then what will happen here? So it is going to take the curved path and tries to move along what? Tries to move along x direction. Understood? Okay. So finally, what is the path it is tracing here? What is the path it is tracing? It is going to trace what? It is going to trace a circular path. So here what is happening whenever the charge is moving in a uniform B field? What is happening? What is happening? So the magnetic force is not changing the speed of the moving charge. What it is doing here? It can at most changing the direction of what? Changing the direction of moving charge. So initially it is moving along Ex, then a force is acting in this direction. Because of this force, it has changed its direction and starts moving along Y. Now here the force is acting along negative X direction. Again it takes curved path and tries to move along this direction, and whenever it is moving in this direction, the force is acting downward. So then again it will take curved path and tries to move along negative y direction. Whenever it is moving in negative y direction, it is experiencing a force in x direction. So it is going to take a curved path and tries to move along what? Tries to move along x direction. So in this manner, it is going to trace what? It is going to trace a circular path. A circular path. Now let us consider the radius of this circular path here. Let us consider the radius of this circular path is capital R. Capital R. Okay, right? Okay. So the radius of this circle is nothing but what? Is nothing but capital R. Now I want to determine this radius of the circle here. I want to determine the radius of the circle. Okay, so here you have to understand one more thing here. Here you have to understand one more thing. That is B field. B field is pointing in which direction here? B field is always pointing in which direction? It is pointing in negative z direction. And the velocity here, velocity is always present in which plane? It is present in xy plane. It is present in xy plane. So velocity is in xy plane, and B field is what? B field is perpendicular to this xy plane. So that means the angle between the velocity and B field is how much here? Tell me. What is the angle between velocity and B field? Tell me. The velocity is in xy plane and B field is in negative z direction. So that means what is the angle between the velocity and what? And B field. Tell me here. Tell me. What is the angle between velocity and B field? Tell me, in this case, what is the velocity between, what is the angle between velocity and B field? Tell me here. Rahul Thakur, Paras Moon. Rahul Thakur. Thank you Thakur. Right. So tell me here. What is the angle? Alok Kumar. 90 degrees. Okay. So angle is nothing but what? Now here in this case angle between V bar and B bar is how much here? 90 degrees. 90 degrees. Yes. Okay. Okay, so that means what we can conclude here? What we can conclude here? Wait here, I will delete all these things. Okay, so that means what is the conclusion we can make? If the angle between, whenever the angle between angle between V bar and B bar, V bar and B bar, that is theta, that is let us say theta is equal to 90 degrees, theta is equal to 90 degrees. So in this case here, in this case, whenever angle between V bar and B bar, that is theta equal to 90 degrees, in this case, the path traced by the charge is a circular path, is a circular path. In which plane here? In which plane it is tracing the circular path? It is tracing the circular path in a plane that is perpendicular to what? That is perpendicular to B field. Yes or no? Okay. So the path traced by the charge is a circular path in a plane, that is perpendicular to what? That is perpendicular to B field. So this point is very, very important here. So whenever angle between V bar and B bar is 90 degrees, then the path traced by the charge is a circular path in a plane, that is perpendicular to what? That is perpendicular to B field. Okay. If suppose okay, if suppose the velocity is in YZ plane, that means it is tracing the circular path in YZ plane, then B field must be in which direction? B field must be in X direction. Understood? It may be plus X or minus X, it doesn't matter. Right? Okay. But always the angle between V bar and B bar is equal to 90 degrees means that the path traced by the charge is a circular path in a plane that is perpendicular to what? That is perpendicular to B field. So this is the conclusion. This is the conclusion we can draw here. This is the conclusion we can draw. Okay. This is the conclusion we can draw. Right? Okay. Now see here. Now I want to determine the radius of this circle here. I want to determine the radius of this circle. How I can determine the radius of this circle here? See here, whenever the charge is moving here, whenever the charge is tracing this circular path, a magnetic force is acting on the charge. A magnetic force is acting on the charge, and this magnetic force is trying to pull the charge. Yes or no? This magnetic force is trying to pull the charge towards what? Towards the center. Yes or no? Okay. So here the charge is tracing a circular path. Whenever the charge is tracing a circular path, a magnetic force is trying to pull that charge towards the center of the circle. So this magnetic force is acting like what here? See, whenever a particle is moving in a circular path, a force is trying to pull that particle towards what? Towards the center. That force we call it as what? That force we call it as centripetal force. That force is called as centripetal force. Now here our magnetic force is acting as what? Is acting as centripetal force. Yes or no here? So whenever the charge is moving, whenever the charge is tracing a circular path, this magnetic force is trying to pull the charge towards what? Towards the center. So that force we call it as what? We call it as centripetal force. Here our magnetic force itself is acting as what? Is acting as centripetal force. Understood? Okay. So that means I can say the magnetic force is acting as what here? The magnetic force. I am considering only magnitude here. So the magnitude of magnetic force is acting like what? Is acting like a centripetal force. Understood? And we know that the centripetal force is equal to what? Is equal to mv square by r. So this is the centripetal force here. So centripetal force is equal to what? mv square by r. Okay. So now here this magnetic force, we know that magnetic force is equal to what? Q into V bar cross B bar. So that is equal to what? Q into V bar cross B bar, that is equal to, I can write it as what? QVB sin theta. QVB sin theta. I am writing only magnitude here. I can write it as QVB sin theta. And here in this case, theta is what? Theta is 90 degrees. That means sin 90 will become what? Will become 1. So that means here I can write this magnetic force as what? Simply Q into what? Q into V into B. That is equal to what? That is equal to mv square divided by what? Divided by r. mv square divided by r. Okay. So mv square divided by r. So now here this v and here v will get cancelled. Therefore from here I can determine what? Radius of the circle. So what is the radius of the circle? R is equal to what? R is equal to mv by what? mv by q into b. mv by q into b. So this is the radius of the circle. This is the expression for the radius of the circle, right? Okay. Okay, Parasmoon, can we have a spherical path if both velocity and b field changing direction in 3D? Spherical path, I don't think so, yeah. I don't think so, right? I don't think so, Parasmoon. See, it is going to trace the circular path when, what is the condition? When theta is equal to what? When theta is equal to 90 degrees. When theta equal to 90 degrees, then only all these things will happen. Understood? Okay. Okay, yaar. Right? Okay. So if you consider b field somewhere here, understood? So then also you have to consider the velocity. The velocity must be perpendicular to what? Perpendicular to b field. Then only it is going to trace what? Then it is going to trace a circular path in a plane that is perpendicular to what? That is perpendicular to b field. So it is not going to trace a spherical path here. It is not going to trace a spherical path. It is going to trace what? It is going to trace a circular path when theta is equal to what? When theta is equal to 90 degrees. Understood? See, if you consider some b field somewhere here, okay, some in 3-dimensional space you have considered somewhere here. So then for this b field you are going to have what? You have to consider a plane. You have to consider a plane that is perpendicular to what? That is perpendicular to b field. Yes or no? And the velocity will be must be present in the plane. The velocity must be present in a plane that is perpendicular to what? That is perpendicular to b field. Yes or no? Then only this case will occur. Understood? Okay, so that's what I have told here. That's what I have told. The path traced by the charge is a circular path in a plane that is perpendicular to what? That is perpendicular to b field. Understood? Okay, so when theta is equal to 90 degrees, when theta is equal to 90 degrees, right? So it is not going to trace here. It is not going to trace a spherical path, Parasmoon. It is going to trace circular path when theta equal to 90 degrees. Right? Is it clear, Parasmoon? Whatever the direction you can take here, b field, what I am saying here, the condition is theta must be equal to 90 degrees. That means the velocity direction and b field both must be what? Both must be perpendicular to one another. It happens if and only if what? If and only if the velocity, the plane in which you are considering the velocity, that must be perpendicular to what? That must be perpendicular to b field. Then only it is going to happen. So if you are considering a plane means, if you are considering a plane in which, what I am saying here, you have to consider a plane, that is what? That is perpendicular to b field. Understood? Okay. Okay, yeah. Okay, so this is the radius here. Radius is equal to what? mv by qb. Okay, so is there any doubts here up till now? Tell me. Is there any doubts up till now? Tell me here. Tell me. Rahul Thakur, Alok Kumar. Tell me here, is it clear? How you are determining the radius of the circular path and how we are getting the circular path? Is everything clear? Tell me. No sir. What is your doubt here? Rahul Thakur, what is your doubt? No doubt sir. No, Rahul Thakur is saying no sir. That means you are not having any doubt, right? Okay, fine. Parasmoon, is it clear? Parasmoon, tell me here, is it clear? Okay. Okay, yeah. So this is how you have to determine the radius of the circular path that is traced by the charge, and it will happen if and only if theta is equal to 90 degrees. Understood? Okay, that is the angle between what? Angle between V bar and B bar is equal to 90 degrees. Then it is going to trace the circular path in a B field. Now here the magnetic force itself is going to act like a centripetal force. So by using that, we have determined the radius of the circular path. Okay, so with this I am winding up the session here for today. So tomorrow we will see what happens if theta is not equal to what? If theta is not equal to 90 degrees, then what happens? Then what is the path traced by the charge? Okay, so all these things we will see in the tomorrow's session here. Okay, so I hope whatever we have covered today, I hope it is crystal clear, right? Okay, and I hope you are having no doubts up till this topic, right? Okay, yeah. So tomorrow we are going to meet exactly at what? Exactly at 4 p.m. at the same timing here, same timing. Understood? Okay, so with this I am okay. Parasmoon, that's what I said now. If theta is not equal to 90, then what will happen? That we will discuss tomorrow here. That's what I am saying, right? So today we have discussed what happens if theta equal to 90 degrees. Tomorrow we will discuss what happens or what is the path traced by the charge if theta is not equal to 90 degrees. So those things we will discuss tomorrow, right? Okay, okay, yeah. So tomorrow we are going to meet exactly at what? Exactly at 4 p.m. here. So with this I am winding up the session for today, and tomorrow we will meet exactly at 4 p.m. at the same time, right? Okay, okay, yeah. Okay, okay, yeah. So okay guys, be safe and stay safe and keep learning. So we'll meet tomorrow. So until then, take care. Bye bye.